right, welcome to The Explainer. Today, we are diving into something that is truly at the very heart of all programming, how we get a computer to make a decision. This is the secret sauce, the magic that makes all of our software feel smart. So let's pull back the curtain and see exactly how it's done. I mean, have you ever stopped to think about it? Every single time you interact with your phone, a decision is being made behind the scenes. Is that password you just typed in correct? Did you hit the like button or the share button? Did your character in a game have enough experience points to level up? Well, the answer to all of those questions comes down to one simple, powerful idea, a conditional. So here's what we're going to cover. First, we'll look at the absolute core of how code makes any decision. Then we'll get into the rules it uses to compare things. After that, we'll tackle a famous little quirk in JavaScript that catches everyone out at first. From there, we'll build up to more powerful logic, and finally, we'll check out a handy alternative called a switch. All right, let's get right to it. The single most fundamental tool for making decisions in pretty much any programming language is what's called an if statement. And you know what? That's really all there is to it. It's the exact same logic we humans use constantly. If I'm hungry, then I'll get a snack. If it's Tuesday, then I have to take out the trash. Code just gives us a formal way to write this down. It checks if some condition is true, and if and only if it's true, it will run a specific chunk of code. So the keyword there is true. The if statement is basically asking a question that can only have one of two answers, true or false. Is the user logged in? True or false? Is the score greater than 100? True or false? And based on that simple answer, the code knows whether to execute the next step or to just skip it entirely. Let's make this real. We all learn this in math class, right? The absolute value of 5 is just 5. But the absolute value of -5 is also 5. The rule is incredibly simple. If a number is negative, you just flip its sign. We can express that perfectly with an if statement. The code would ask, is this number less than 0? If the answer is true, it runs the code to multiply it by -1. If the answer is false, it just does nothing. It skips right over it. Okay, but that brings up a good question. For that if statement to work, how does the computer actually know how to compare things? It needs a vocabulary to ask these questions, right? A way to understand, is this bigger than that, or are these two things the exact same? And that's where comparison operators come into play. So here they are, our basic tools. Most of these are pretty familiar, right? Greater than, less than, but I want you to look very closely at equal to. See how it uses two equal signs? This is a huge deal in programming. A single equal sign means you're assigning a value, like setting a variable. Two equal signs means you're asking a question, are these two things equal? And every single one of these expressions boils down to that simple true or false answer that our if statement needs. And get this, it's not just for numbers. You can compare text or strings too. When you ask if apple is less than banana, the computer goes letter by letter, alphabetically, to figure it out. And here's a fun little piece of trivia. This means that the string sunny is actually considered greater than the string sun. Why? Because the first three letters are the same, but sunny is longer. Kinda neat, right? All right, buckle up, because this is where we have to talk about something a little strange about JavaScript. This is one of those classic gotchas that you absolutely have to know about if you want to avoid some really confusing bugs down the road. This is the idea at the center of it all. Weak typing basically means JavaScript tries really, really hard to be helpful. Sometimes a little too helpful. See, if you try to compare two different types of data, like, say, a number and a string of text, JavaScript doesn't throw an error. Nope. Instead, it tries to secretly convert one of them to match the other before it gives you an answer. So, quick pop quiz. What do you think happens here? We're asking the computer if this string of text 2 is greater than the number 1. Now, logically, that seems like nonsense, doesn't it? How can a piece of text be greater than a number? What does that even mean? And the answer is true. It's true. So what happened? Well, JavaScript's weak typing kicked in. It saw you were trying to compare a string to a number, and it said, oh, I think I know what you mean. It converted the string 2 into the number 2 behind the scenes, and then it compared the number 2 to the number 1. And since 2 is greater than 1, the result is true. You can see how this could get you into trouble if you're not expecting it. So how do we protect ourselves from this? How do we get around this weirdness? We use this, the strict equality operator. 3 equal signs. This is the hero of our story. See, the double equals is loose. It'll do that weird type conversion, which is why it thinks the number 5 and the string 5 are the same. But the triple equals is strict. It checks for two things. Is the value the same? And is the data type the same? And since a number is not the same type as a string, it correctly says false. Pro tip, Just use triple equals all the time. Your code will be safer and way more predictable. Okay, so we've got our basic if statement down, and we know how to compare things properly using strict equality. But real life is rarely just a single yes or no question, right? So let's look at how we can start to build more complex, branching paths for our code to follow. This is the classic if-else chain. Think of it like a waterfall. The code starts at the top and checks the first if condition. If it's true, it runs that code and then it's done. It skips the rest of the chain completely. But if it's false, it flows down to the next step, the else if, and checks that condition. You can have as many of these as you want. And if it goes through all the checks and none of them were true, it finally lands in the else block at the bottom, which is like a catch-all default action. But what if you need to check a couple of things at the same time? Well, that's where logical operators come in. The double ampersand and means and. This is for when you need condition A and condition B to both be true. For example, to check if a number is between 2 and 7, you need it to be greater than or equal to 2 and less than or equal to 7. The double pipe, or, means or. This one's true if either condition A or condition B is true. You just need one of them to pass. And finally, the exclamation point, not, just means not. It flips the whole result. It turns a true into a false and a false into a true. Now that if-else chain is going to be your workhorse. You'll use it all the time. But there is another tool that for certain specific situations can be a lot cleaner. It's called a switch statement, and it's perfect for when you have one single variable that could be one of several different specific values. The way it works is pretty simple. You give the switch a variable you want it to look at. It then jumps down the list of possible cases until it finds a match. Once it finds one, it starts running the code inside. But now, look at step 4. The break statement. This is super important. The break is like a stop sign. It tells the computer, okay, we found the right one, we're done here, get out of the switch. If you forget it, the code will just keep on going and run the code in the next case too, which is usually not what you want. And just like else, the default block is the fallback if nothing matches. So when do you use which one? The rule of thumb is pretty simple. For anything complex, like checking number ranges or combining different variables with and or, you're going to use if-else. It's the flexible, powerful tool you'll use 99% of the time. But if you find yourself checking one single variable against a list of specific things, like checking the day of the week, a switch statement is often way cleaner and much easier to read. And really, that's the big takeaway here. It might seem like a handful of simple rules, but when you start combining these if, else, and switch statements together, you create the incredibly complex logic that powers everything we use. Every app menu, every decision an enemy makes in a video game, it all boils down to a foundation of these simple true or false questions. All right, so to wrap it all up, remember, if, else if, and else are your main tools for making your code go down different paths. Please always use the triple equals, the strict comparison, to avoid those weird JavaScript surprises. You can build more powerful logic by combining conditions with and or. And finally, if you're checking one variable against a list of options, a switch can make your code look much nicer. So that next time you click a button, swipe on your screen, or type anything into a computer, just remember, somewhere under the hood, a tiny if statement is making a decision. It's a chain reaction of simple true or false questions being asked thousands of times a second. These really are the fundamental building blocks of software. So the only question left is, what decisions are you going to teach your code to make?